Hey class, so in this video I'm going to talk to you about the measurement lab review sheet. You should complete all the answers on your review sheet and turn it in on the day of the final. Okay, so you can describe how, the first question says, describe how to measure the mass of an object using an electronic balance. So the first thing people have said is to turn on the scale. I guess we can write that down. Remember when we reviewed this in class? That's what some people said. So turn on the scale. And then you're going to want to place the weigh boat on the scale. And then you want to hit the tear button. Sorry about my mess there. You want to tear it so you're not going to take the weight of the weigh boat. Alternatively, you could write down the mass and you could subtract it, but you could just have the machine do that for you. Then you place your sample in the weigh boat. And then you read the mass. And that's about it. The key is to make sure that you know that when you put something on a scale, if you don't tear it, you're going to be weighing everything that is on the scale. When you turn on the scale, it should already say 0. But if the scale is already on, you want to make sure that you also tear the scale, right? So before you put any object on the scale that you want to weigh. Okay, number 2. Describe how to measure the volume of an object using water displacement. So the first thing is you put water in the graduated cylinder. And the second one would be to put the object in the water, the thing that you want to find the volume of. Number 3, sorry, I forgot here. When you put the water in the graduated cylinder, you want to read the initial volume. Otherwise, you have no idea what the change in the volume is going to be. My apologies for skipping that. So you put the water in the graduated cylinder, you read the initial volume, you put the object in the graduated cylinder, and then you read the final volume. The final volume has the symbol VF. The initial volume has the symbol VI. And step number 4, you would say that the volume of the sample is the final volume minus the initial volume. Okay. The third question asks, describe the difference between accuracy and precision. So accuracy is the closeness to the correct answer. If you're playing darts, for example, when you're getting the bullseye, that's very close to the right answer, or that is the right answer. So any darts that are close to the bullseye would be accurate. Precision would be the closeness of measurements to each other. So if I give you a graduated cylinder and a bunch of measurements that you do of the same sample are equal or very close to each other, that would be their precision. It may not be the correct answer because no one, as we said in class, no one actually knows what the correct answer to a measurement is, because you can always get more and more accurate, more and more close to the correct answer, but no one actually knows what that measurement would actually be. In the case of the darts example, if you get a bunch of the darts really close to each other but they're not in the bullseye, then that would be an example of precision but not accurate. If you throw a bunch of darts and they're all near the bullseye, that would be accurate and precise. Question number 4 here. Describe how to make a volume measurement using a graduated cylinder. So here's my graduated cylinder with a bunch of lines on it, right? The graduations are major scale and minor scale divisions. You want to put your eye, so this is my eye here, and you want to be at the level. So you have to put your eye at the level. Oops. At the, it's 2 words, but it looks like 1 word. Eye at the level of the water, of the liquid. 2 is you read the volume at the meniscus. So the meniscus is the curve in the liquid. Most liquids, especially like water, they adhere, they stick to the side of the graduated cylinder, and so you'll get a curve that looks like that. And you want to read the liquid at that level right here, not right there, right? One step that I probably should have put up here, as if you call this 1B, 1A would be place the graduated cylinder on a flat surface. Cylinder on a flat surface. Again, sorry about my messy handwriting, but I am trying to also say what I'm writing so it's clear to you. Number 5, explain the relationship of uncertainty and digits in graduated cylinder and digital scale measurements. So if you have a digital scale, this is kind of a top view. Here's your scale, and my measurement is 3.5 grams. We always know that last digit is the uncertain value. Remember, we're always guessing only 1 digit. So in this case, the digital scale is making the guess of that last digit in the measurement. When you're using a graduated cylinder, I'm going to blow this up a little bit in size. If your measurement, if the only lines you have are 43 and 42 and the liquid is in between 43 and 42, we want to make that guess, right? 1 digit guess. That's the uncertain value, the one that we had mentioned for the scale as well. So in this case, it may be like 42.3 milliliters. And that's just an example, right? It's somewhere halfway in between, just below halfway in between 42 and 43. So you guess 1 more digit. So the significant figures in a measurement come from the certain digits, which depend on what the major and the minor scale divisions are, and then the uncertain digits, which is always only 1 digit. Number 6 here, I'm going to move this down. Number 6 here is provide an example of experimental error. So experimental error, firstly, you have to know, is not a mistake. It's basically variations in an experiment, variations in results from an experiment that occur naturally. So if we were to place calcium chloride, the same amount of calcium chloride in the same amount of water. So for example, if I put 5 grams of calcium chloride in 100 milliliters of water, and I was to put a thermometer in there, sorry about that mess. If I was to put a thermometer in there to measure the temperature, remember in the first lab we did, when you put the calcium chloride in the baggie, it turned hot. It became hot. So if I put 5 grams of calcium chloride in 100 milliliters of water and I measure the maximum temperature using a thermometer, then when I measure the maximum temperature, every time I do this, no matter how many times I do it, I'm going to get slightly different results every time because of variations in small variations in thermometer readings, in volumes, in masses, in random movements of molecules. So this variation, the differences in measurement, come from experimental error. It's not about making mistakes, spilling things in the lab, etc. Okay. Number 7, draw a beaker, pipette, and a graduated cylinder. So a beaker looks like this. A pipette, the Burrell type pipette that we used in the lab, looks like that. These both have kind of some general lines on them. And a graduated cylinder, which we've talked about already on this review sheet, which has a whole bunch of major and minor scale divisions. Which ones of these, this question should have said ones, and this one should have said Burrell type pipette, should not be used? Well, the answer would be these two, because these lines are just suggestions. In the very first measurement lab that we did, when you measured water in a graduated cylinder and poured it in the beaker and realized, hey, wait, these lines, they're not that accurate. They're just suggestions. Really, the reason why we use beakers is because they're larger, you can stir, you can mix. That's what a beaker is for. And so you can't really stir because the graduated cylinder is too narrow. So these lines are just suggestions. And so they can give us approximate answers. Same thing for a pipette. A pipette is only just a suggestion of a very small volume. You can buy actually very expensive equipment to measure very, very small volumes. Question number 8. If you have a 100 milliliter and 50 milliliter graduated cylinder, which one of these should be used to measure a volume close to 45 milliliters or 55 milliliters? So if you have a 45 milliliter volume, you would use a 50 milliliter graduated cylinder. And the reason is because it's close to the capacity. Close to the capacity. You always want to be able to use a graduated cylinder near its capacity, because at the bottom of a graduated cylinder it can be harder to read. Sometimes the lines don't start till some part of the way up. And it would be perfectly valid to use a 45 milliliter graduated cylinder for 100, but the 50 milliliter graduated cylinder has more divisions. It has more divisions. So you can get more precise answers, or more accurate, more closer to the correct answer. So for the 55 milliliter volume, you can't use the 50 milliliter graduated cylinder. You can't use it. And the reason is because it exceeds the capacity. Right? Capacity means how much something can hold. So you would use the 100 milliliter graduated cylinder because the liquid can actually fit inside. So I think I have addressed all those issues in the question. And lastly, number 9, redraw below a section of the graduated cylinder that you see to the right, and draw where the liquid should be. So here's a graduated cylinder. Here's my 43 mark. Here's my 42 mark. And 42.7 is about here. And we also know that it's a meniscus. So there's a meniscus, so we're going to do a little curve. That's not perfect, but it's close enough. Again, it's a multiple choice exam, so you're going to be able to choose what the correct answer is. Okay, and that's it. So please make sure you've written all these answers in complete sentences, and then you're going to study this and turn this in on the day of the exam. Hope this was helpful. Have a good one. Bye.